What's up, math scholars? Bigger minus smaller, and you'll become a math scholar. I have a little song to teach you in a couple minutes, and that's a funny little variation of the song. But hey, who's excited to learn 2 more properties on the property sheet? Woo! They used to be so enthusiastic with these, but they're tired today. Alright, so on Monday, we did the first 3 properties on your property sheet. Today we're doing quotient of powers and power of a quotient. Quotient of the powers, I have a little bit of song to sing you. I wrote it on my whiteboard so the students were writing it down, but it goes like this. Bigger minus smaller. Put your answer where the bigger lived. Or, bigger minus smaller, you'll be a math scholar, but put that answer where the bigger lived. That's a little too much. So let's look at the problem. This is the first example problem you have on the right about, here. I just put it on the next slide to make it bigger. Okay, so here's how it works. We're going to look at our A's first. You see how on the top I have an A to the 10th? Yep. And on the bottom I have an A squared? Yeah. Which one's bigger, the A to the 10th or the A squared? 10. The 10. So you're going to do 10 minus 2. Bigger minus smaller. 10 minus 2 equals 8. But the answer of A to the 8th is going to go up top because that's where the bigger one lived. Now you might be wondering why. Why is that? The true math scholars are always asking me why. So I'm going to show you visually why that works. A to the 10th means we have 10 A's living up top. A squared means we have 2 living down below. And you know what happens when things live up above and down below? They cancel. So basically, me doing 10 minus 2 just helps me figure out how many are left after all the canceling happens. There's 8 left. Exactly. 8 on the top. Does that make sense? All right, so now let's do our B's. We have B to the 9th, and we have B to the 4th. Which one's bigger? 9. So we're going to do bigger minus smaller. We're going to get 5, B to the 5th, and we're going to put the answer where the bigger lived. Where's the bigger live? Up top. So to tell you the truth, there's nobody down below in my final answer. My final answer is A to the 8th, B to the 5th. Do you see it? Hey, while I had the video on pause, we actually drew our B's out as well, just to demonstrate why there's nobody in the denominator anymore. There's nobody down below anymore, because those 2 A's canceled out, and the 4 B's canceled out. So everybody that's left all lives in the numerator on the top. So just a real quick refresher, the top is called the numerator, because you'll hear me say these words today. And the bottom is called the denominator, so be good with your vocabulary. I don't know what grade you learned numerator and denominator in. 4th grade? Okay. So you guys should be familiar with those words. This is the next example that's on the little sheet on the right. Now, one thing to keep in mind is normal numbers don't behave the way exponents do. So I'm not going to do 12 minus 6. Those are just normal numbers. What do you think I'm going to do with the 12 and the 6, Ken?
You'll get, you do the subtraction, and you get 12x1 over.
Okay, I do agree with the x1. However, because he did 7 minus 6, put the answer where the bigger was. But the question was, how do you deal with the 12 over 6? Because they're normal numbers. They're not exponents. Cassian? Yeah, and what is 12 divided by 6? 2 over 1. So you can just put a 2 there. All right, Ken, you left me hanging. I need you to do my y's. Bigger minus smaller. Put your answer where the bigger lived. Where is it going to go? Y5, but on top or on bottom? On top, because that's where the bigger lived. There's nobody on bottom again. That's kind of weird. There will be people on the bottom. That was just those 2 examples were weird. Hello, people in the video. A student asked to see an example of something that would have someone living in the denominator in the final answer. So let me make up a good one. 2 over 6, x to the 7th, x to the 5th, m to the 8th, m to the 1st. You can just write this down where you have some space. Let's start with our just normal numbers, our 2 over 6. 2 over 6 is just a normal fraction. You've been doing fractions since 4th grade, people tell me. So how would 2 over 6 reduce down? 1/3. So you divide the top by 2, get 1. Divide the bottom by 2, get 3. 2/6 is 1/3. Let's do our x's. Bigger minus smaller, put your answer where the bigger lived. So how many x's would I have and where would they live? Good job, and where would they live? On the top, because the bigger one was a 7, and it was on the top. How about our m's? Bigger minus smaller. Put your answer where the bigger lived. It's written m to the 7. M to the 7th on the bottom. Now, question for you guys. Mathematically, could I pick up my eraser, erase that 1, and still be okay?
Yeah.
Yeah, because at least there's something on top. You have to have something on top. It can't be empty on top. But since our x squared's on top, we're good. Ken? My class is being very, very scholarly today and asking the best questions. They just asked to see something that maybe everybody would live on the bottom at the end. So let's see something like that. How about we go with m to the 10th over m to the 13th, n to the 15th over n to the 16th. Okay, I think I have made an example where everybody will be on bottom. Jose? Okay. And?
And 1.
At the bottom. Now you don't really need the 1. You can put it. So now we have this little situation where our numerator's empty. You think I should just plop any old number up there just to fill some space? What would I do? Anybody know? No, you don't want to leave blank. You never want to leave anything blank. You put a 1 there. A 1 is kind of like a placeholder, and it doesn't really have any value, so it just holds that numerator in place. Okay? Great questions. I love that. All right, our last property today is called power of a quotient, but basically if you have something being divided with a power up front, the power distributes in. See, I just end up drawing a bunch of rainbows. So over here I would draw a rainbow to there, rainbow to there, rainbow to there, rainbow to there, and rainbow to there. Now that's a lot of rainbows. So I'm going to go to the slide where I have this problem written a little bit bigger. I just blew it up so we'd have more space. So we're rainbowing this 3 to the 2. What is 2 to the 3rd power? No. 2 to the 3rd power is 2 times 2 times 2. 8. Very good. Then you're going to rainbow the 3 to the 3. Those two end up multiplying. We learned that the other day. It's power of a power. So what's 3 times 3? So it's a9. A to the 9th. And then this 3 and this 5 will multiply as well. So it's b to the 15th. That takes care of my numerator. Let me get a new color for my denominator. This 3 goes to this 3. What is 3 to the 3rd power? 3 times 3 times 3. Good. And then this 3 goes to that 2 and multiplies. B6. Now you're not done. You want to now finish it off with any other simplifying or properties you can. I don't think I can do anything with the a's, so I think I'm just going to have an a to the 9th on the top. Can I reduce down the 8 over 27 at all? I don't think so either. So it just stays an 8 over 27. But I think I could do something with my b's. Bigger minus smaller. Put your answer where the bigger lived. What would it be? 3 to the 9th on the top or the bottom? Good. 3 to the 9th on the top. There's a lot going on in that problem. We're just going to use the quotient properties. We're not actually going to type these in because they'll be pretty big answers. What could I do on part A? I'm looking for a scholar with a plan. Garrett?
You just subtract 10 minus 4.
Good. So good job. And we're going to leave it as an 8. I know it's so tempting to think 8 divided by 8 is 1, but 8 is acting as the base. So take the base, leave the base the same, subtract the powers.
Well, couldn't it be like 1 and 6? Or like if you have
The problem is, like, if the 8's not acting as a coefficient, the 8 is acting as the base, so you leave it in 8. Because here's what's happening. Let me show you visually what's happening. You have 10 8s on top. That's one 8s. And then you have 4 8s on bottom. So see how 4 of them cancel? So you are canceling 8s. I know you wanted to cancel 8 and write 1. 4 of them cancel. But you're still having 6 left.
But technically, it's an invisible line.
Alright. Right. Alright, part B. Brad, what do you think?
Well, I had a question for him.
Oh, okay. All right. Everybody think they know part B? Scholar. Scholar with the plan. Who's got a plan? Right? We're going to leave the base on -3. We just need to know what the exponent would be. Take the bigger exponent, subtract off the smaller exponent, 6, and put the answer with the bigger exponent and live on top.
Poor buddy.
I come to this very easy problem, but they want to do board buddies really bad, so I'm going to send some more buddies out. All right, everybody was super scholarly. You just take the 3 and give it to everybody. It was that easy.
You don't even have parentheses. How do we?
All right, well, we're going to up the difficulty level and see how the buddies do with this one. All right, we definitely had some conversations going on up here. Listen up, we're on the video. 4 to the 3rd would be 4 times 4 times 4. So there were some 12s up here and some erasing, but it is 64. Now this 2 and this 3 need to multiply together. So that should be a 6, actually. I don't know where the 8 was coming from. Oh, because you did 2 to the 3rd. They're just exponents. Exponent rules of power to a power would be to multiply. And then 5 to the 3rd would be 5 times 5 times 5. And then this should be y to the 3rd. So I think we're all fixed now. And there's so many little... Yeah, with these, there's so many tiny places to make mistakes. You got to be careful. We're going to give this a try, see how it goes. Alrighty! The video is on pause, so you guys at home don't realize they just took an hour to do this. Let's talk. These 2 will multiply, become a 10, so I agree with that part of it. This will distribute to here, so I agree with that part of it. And then you could kind of put everybody in one big fraction together. So I don't know if you knew that, the a to the 10th would be on the top. The b to the 5th with the 2a to the 2nd can all be on the bottom together. I'm in one huge fraction. Let's simplify it down. Bigger minus smaller would be 10 minus 2. That'd be an 8. So there's an a to the 8 on the top. Good. And then the bottom would just be that 2 and that b to the 5th. So good job. If you got this, which it looks like this group did. This group's just sloppy, so I can't tell what they got. This group got it. You guys did pretty well. Good job. That was a hard one. Very good job. All right, this one's going to be a graduation problem. Do it at your seat on your paper, and then we'll check it in about a couple minutes. All right, so that 3 had to go everywhere. 3 got raised to the 3rd power, 27. The 5 and the 3 multiplied, 15. 7 got raised to the 3rd power, 343. And then y got raised to the 3rd power, the 2 and the 3 multiplied to get 6. Now here's where I was experimenting a little. I didn't know if that 27 over 343 would cancel at all. I was like, well, they kind of look like they would both be divisible by 3, right? So what you can actually do is you can type this into your calculator and then hit math, enter, enter. And if it can reduce, the calculator will reduce it for you. Unfortunately, it stayed at 27 over 343, so it is in lowest terms. I was actually surprised 343 was not divisible by 3. It was not. So, hey, who graduated?
Woo!
And who has questions? Woo! So we're back in varsity learn for a second night, 7-2. If you still can't get in there and you don't know your password, please see me before you leave. We want to get you in there.